Hello, everybody. Today is going to be a short little video about atomic testing during the Cold War. So there's not a whole, sorry, adjusting my little camera there. Okay, so the state of California just wants you to know a whole lot about this. It's going to be atomic testing and some nuclear weapon stuff. So look, you guys know already that we've detonated atomic bombs during World War II. We dropped them against the Japanese. So that's not a surprise to you. I mean, that's you know about their existence. What you don't know is that we continue to improve them. The first atomic bombs were destructive, but they weren't as destructive as we wanted them to be. And the problem is that the Soviets very quickly build their own atomic bomb. So once they build an atomic bomb, we make the decision that we want to build a stronger. We want to build stronger atomic weapons, and then we want to build nuclear weapons. Um, and nuclear weapons are the step up from atomic weapons. So very quickly, and then they start building nuclear weapons, and then we want to build larger nuclear weapons that are more destructive, and and then we have to test all those. So it becomes this kind of an arms race. It becomes a nuclear arms race. So we're building bombs, they're building bombs. We're developing new ways of testing those weapons. New ways of detonating them, new ways of delivering them. The Soviets are doing the same thing, and very quickly, before you know it, we've done dozens and dozens of nuclear tests and atomic tests above ground, and the Soviets have done dozens of atomic tests. So let me show you why that's kind of a big deal. So um, let's get into it. So we detonate somewhere between 90 and 100 atomic weapons in Las Vegas. The area at the time when we were detonating them, it's mostly just desert out there. I'm not sure when, and we don't detonate them too close to Las Vegas. So I said Las Vegas, I meant Nevada. But in the state of Nevada, we detonate a lot of atomic weapons. Okay. And if I remember correctly, you could take a tour from Las Vegas where you get in a helicopter and they fly you out to, you could see these gigantic blast craters. I think I have pictures of what that looks like, by the way. Yeah, you could see these blast craters that were detonated out in Las Vegas, where these are below ground tests. So there's two types of tests you need to know about. There's atmospheric tests, and atmospheric tests are tests that are done above ground, like this. And then there's below ground tests, um, underground tests, which are detonated below ground. These were the last tests we did were below ground tests. I don't think we tested all anymore. I can't remember the last time we tested a nuclear weapon. I think most of them are tested virtually in computers now. But I don't even know if we develop nuclear weapons anymore. I think Donald Trump was talking about developing new types of nuclear weapons. But the reality is we haven't done that in a while. The ones we have seem like they work fine, my understanding is. Um, and the Soviets and the United States haven't really spent a lot of time researching new ones, I don't believe. But to be honest, I haven't followed the subject as closely as I probably should. So atmospheric tests. What's the problem with atmospheric tests? So we started detonating these things. I think almost all the tests were done in the southwestern United States, most of them in Nevada. I don't know if we tested any in, I think we tested a few in New Mexico. I don't know if we did any in Arizona. But the problem when you do atmospheric tests like this is that you're detonating an atomic weapon or a nuclear weapon above ground. Let me show you another example of an atmospheric test. This is an atmospheric test. We actually detonated this one in water. This is another atmospheric test. So I think that's a test that was done in the Soviet Union, if I remember correctly, but I'm not sure. But the problem with atmospheric tests like this is that we had people around at a lot of these things. In fact, I've seen, where they dug trenches around where, where they're about to blow up the bomb, and you had American soldiers in these trenches, and they detonate one of these things, and the blast would pass over these guys, and the pressure wave would pass over them, and they would wear goggles so they could see okay, and but we didn't know about the radiation. And so these guys would survive the blast. They weren't so close that it was dangerous in terms of the blast and the radiation. Or sorry, but the light pulse and the radiation. Sorry, I keep saying radiation. Pressure wave. The radiation was something we weren't really aware of. We didn't know, and it's through this testing and through observation of what happened at Hiroshima and Nagasaki, we start to realize that, whoa, something's killing these guys. These guys are getting high rates of cancer, thyroid cancer, leukemia. I mean, you're getting, and it's not just the guys around. It's not just the people that were at the tests, but the people that are 10, 15 miles away. Start getting cancer too. And what happens is we slowly start to discover what radiation is. Now, radiation is a little bit difficult to describe to people. You can't see it, you can't touch it, you can't feel it, you can't taste it. But radiation, if something is radioactive, it's throwing out radiation. Radiation is this harmful energy. It hits your body, and the radioactive particles hit your body, and they start damaging the DNA in your cells, which means it starts causing cancer. It starts to cause damage to your body. Sometimes it doesn't cause cancer. You can actually die if you get enough. The problem with radiation is our bodies soak it up like sponges, and you can't get rid of it. So, and it can start to cause damage in your cells. It could also kill you just right off the bat. You soak up enough radiation, and you'll die of radiation poisoning. But here's the problem. Each one of these blasts is radioactive. So anybody around it starts getting radiation poisoning. Okay. Massive amounts. But what's even worse is that these people don't even know they're getting radiation poisoning until they start vomiting blood, or, they get these open sores called keloids that pop up on their skin. So they don't know until their hair starts falling and stuff, that they've soaked up that much radiation. They start getting sick to their stomach and vomiting blood. But it's even worse because this dust from these blasts gets picked up in these giant clouds, and all that dust is now radioactive. So it's throwing off radiation. So when the wind blows, it starts blowing that dust. It could blow that dust, 20, 30 miles away. So you get, the dust coming in, the dust rising up, the wind coming, blowing that dust maybe 40, 50 miles, and it settles on a city where all those dust particles start falling on people's homes. I mean, guys, you're looking at wherever the wind pattern is. Let me show you on Google Maps. You have blasts being done in here, out in Nevada, right? And the wind could pick that stuff up. The dust from those blasts, that's called fallout, by the way. Radioactive particles that are picked up by the wind and thrown, 20, 30 miles, 40 miles, whatever, that radioactive dust is now called fallout. Eventually it falls down from the sky. It could fall down in Denver. They could have blown up those bombs out in Nevada. And in Denver, that dust could have settled down on the roof of their homes. You wouldn't know because you can't see it on the roof of your house. You couldn't smell it. You couldn't taste it. You can't, you would just see ash, I guess, if you were lucky to even see the ash or the dust. But it could irradiate everybody in that house. So you can have people start dying you start seeing increased cancer rates in Denver. Guys, wherever the wind patterns are, you start seeing increased cancer rates all down wherever the wind patterns go, because that's where it's going to blow that dust. So that's why we stopped doing atmospheric tests. What we start doing instead of atmospheric tests is, that's an island we blew up. We blew up this island called Bikini Atoll. It's pretty, but that's what these are. These are scars from below ground tests. So we'll take nuclear weapons, dig a small chamber, stick the nuclear weapon in there and detonate it to see, does it blow up? Does it work? What are the effects? How explosive was it? Can we improve it? And the reason why we blow them up below ground is because you don't get that mushroom cloud with all the irradiated dust that goes, flying with the wind. By the time we did these tests, we knew that you have to be careful with atmospheric tests. And not just careful, you can't do them because people are going to die of cancer, far away from the blast. So I don't know how many below ground tests we did, but you could see it. You could see it here, all the scars from these below ground detonations. So that's what's going on with all the nuclear blasts and the atomic testing. So that's all we have to say about that. Now, there is something I want you to understand about the Cold War, and that's what happens when we get into this arms race where we start building, we build weapons and then the Soviet build weapons and then we build more weapons and stronger weapons and they build stronger weapons. And you get this nuclear arms race where pretty soon we have 100 and they have 100 and then we have 1,000 and they have 1,000. And because they have 1,000, then we're going to build, 3,000 and they're going to build 3,000. Pretty soon we're like, well, what if they attack us first? If they attack us first, then we have to have enough nuclear weapons left after the attack to be able to attack them back. So we better build 7,000. So guys, very quickly before you know it, the United States ends up with, I don't remember how many nuclear weapons we had at the height. I think it was around something like 15,000, if I remember correctly. And the Soviets had somewhere around like 12,000. But guys, you're looking at enough weapons to destroy the world. Well, it depends on what you mean by destroy the world. I mean, by the way, when do we stop building them? So eventually we get into this. We have this policy called mutually assured destruction. It was this kind of this understood this agreement. Well, it wasn't really an agreement. It was this understanding that both the United States and the Soviet Union had enough nuclear weapons that if we attack them, they would still be able to survive and destroy us. That we both together have enough nuclear weapons to destroy the other country. So that's why they call it mutually assured destruction, meaning we both understand that if they attack us, they will die. And if we attack them, we will die. We're both guaranteed to die in this thing. If the war goes nuclear, if one of us uses nuclear weapons, then we both, even if they attack us first, will have enough nuclear weapons left to probably destroy their country. Now, what does that mean, destroy their country, guys? I mean, look, when you start throwing around weapons like, the amounts of like 7,000, 8,000 nuclear weapons, you're looking at, I mean, you guys, you would have trouble naming that many targets. And you could say, guys, just imagine this. If, 30, 40 targets in the United States got hit, let's say kids always start off with LA, New York, Chicago, DC, the biggest cities, Seattle, Portland, Detroit, whatever cities you can think of, the biggest cities. You named off 50 cities, just 50 cities. If those, the 50 largest cities in the United States got hit, life would never be the same again, right? The United States, it would take, decades to recover from that probably. And I don't mean just 50. Guys, you have to understand, those cities would be radioactively burned out. You can't just go living in them again. So, and I'm not talking 50 cities getting hit. Let's imagine 3,000, 4,000 nuclear warheads, 5,000, 10,000 nuclear warheads land on the United States. You see what I'm talking about? Now, you may survive the blasts, but let's say you survive the blast. Let's say you climbed into a bunker. All these blasts go off, and then you climb out of the bunker. Okay, here I am. What are you coming out to? What's the world going to look like? Right? Is there going to be a society left? Is there going to be any law left? Is there going to be any government left? Is it people just looting, stealing, killing each other, raping each other? I mean, what kind of society is this going to be? Right? So, and then we're not even sure if the entire world would end, because there was this theory floating around at the time called nuclear winter, where, look, what happens if we detonate? What happens if we detonate 10, 15,000 nuclear weapons or 20,000 nuclear weapons? What happens when all that dust ends up in the atmosphere? what happens when, guys, you have so much dust in the atmosphere that sunlight can't penetrate. Like sunlight can't get through the clouds. There's so much dust that sunlight cannot hit the earth. It's perpetual night. What happens to the plants? Right? Photosynthesis can't occur anymore. And when the plants die, there goes your oxygen. So we're not sure because we've never detonated that many nuclear weapons at once. We don't know what happens. Would the entire sky be blacked out from dust and sunlight can't penetrate to the plants anymore? And all life on the earth dies because oxygen's gone? We don't know. But, anyways, this was a policy during the Cold War. It was a scary time. It was scary because we both understood that if we attacked the Soviet Union, they attacked us, we would both be destroyed. It was called mutually assured destruction. You need to understand it. That was the height of the Cold War. We're still kind of in a state of mutually assured destruction today, understanding we have 1,000 nuclear weapons, they have 1,000 nuclear weapons. To be honest, if they attacked us, if we got into a nuclear war, we both still have enough nuclear weapons to destroy each other, at least destroy life as you know it. And probably it would be that way in most countries that are allied with either one. But let's move on because now you need to know the next step, which is that we do make some progress, guys. We do. It's not all gloom and doom. People start to worry. You start to see protests, right? You start to see protests across the planet about people that say, hey, look, this nuclear situation is scary. You'd see it in every country where people would come out and say, freeze the arm race, no more nukes, no more nukes. And it put pressure. And you know what probably most prompted this was a Cuban Missile Crisis. Guys, remember the Cuban Missile Crisis? We came very, very close to nuclear war. And so what starts to happen is we come right to the edge of a nuclear war. We think the whole world's going to end. People go to bed that night and they don't know if they're going to wake up the next day. They don't know if they're going to see their kids the next day. You go to bed, and when you say goodnight to your kids, you might be saying goodnight for the last time. You don't know if you're going to wake up in the morning. So that scared us. And that started people talking about how we need to fix this. We need to alter the situation. We need to create a situation where there's less nuclear weapons. Well, the first step, and this is a major step, and this actually happened, the SALT I agreement. Let me tell you what the SALT are. We get together with the Soviet Union and we start to talk. Okay, and what are we talking about? We're talking about, can we build, well, first of all, can we stop building new weapons? And that was a major breakthrough. We get together and at the SALT conferences, and that stands for Strategic Arms Limitation Talks, we get together with the Soviet Union and we say, okay, let's see if we can work on some things. Can we stop building some types of nuclear weapons? Okay. And both of us agree that we will. We will stop building some types of nuclear weapons. And we build in structures in this agreement where we can observe them and we can verify, are you really blowing them up? Are you really getting rid of these things? Blowing up's not the right word, by the way. You don't just, because that's a common question I get when we start talking about how do you get rid of a nuclear weapon. You don't just blow it up. What you really do is just kind of dismantle them. You just take them apart. It doesn't make sense to blow them up, right? Because it's dangerous. So we dismantle a bunch of nuclear weapons. Okay, we're not there yet. Right now, we're just at SALT. So we're going to stop building new types. They're going to stop building new types of certain types of nuclear weapons. And that's an important step. It's an important step because it's the first step. We're not used to making treaties with these people. We're not used to making deals with these people. We don't know if we can trust each other. We're very suspicious. It's an important first step because it is a first step. We show that we can work together. We can make the world a little bit safer. And what that does, it leads to the START Treaty. And the START Treaty, I don't remember what it stands for. It's like Strategic Arms Reductions Talks or something like that. But this is a gigantic treaty, guys. You need to know START. Well, you need to know both. The START Treaty, we actually destroy destroy nuclear weapons. We take them apart, dismantle them. Okay, so we cut both the United States and the Soviet Union cut about 25% of the nuclear weapons. There used to be a lot more nuclear weapons around that are still than today. I wish I put some statistics. I didn't do the research on it. I'm sorry. I don't know how many nuclear weapons we have today. I don't know how many Russia has today, but it's a lot less than there used to be. So that's you guys will need to know all that. I'll put up an Edpuzzle on this, so you'll be probably watching this through Edpuzzle. But that's everything you need to know. That's the end of the lecture. Take care, everybody. I'll catch you probably on Wednesday with another. Not Wednesday. Sorry, today is what, Monday? Yeah, Wednesday. Catch you on Wednesday with another video. Well, I'll film it at night. You'll probably see it the next morning. Okay, take care, everybody. Bye.